Hi everyone. In this video, I will be identifying mutations in the mutation plasmid. First, what you're going to want to do is download the sequences that can be found on Moodle that we will be identifying. We will be identifying the plasmid mutation for the MSH2 gene, and as well as the gene that you were giving during class. So for example, some people may have SP0, well, I think everyone has SP0, but SP1, SP2. My particular group has SP4. So that's the gene that we're going to be trying to look for mutations with using APE. Okay, so let's get started. So the first thing that I'm going to do, I'm going to align my sequences so I can find the mutation that's within the gene, the plasmid MSH2 gene. So I'm going to align sequence using APE. And we're going to do the SP4, which is the gene for my particular group, and the plasmid. So I'm going to just press OK. We're aligning the sequence. Okay. And I should be able to find the mutation or the exact spot where the mutation occurs within this particular sequence. And it's right here. And as you can see, it occurs at 5,487 to 5,488. So that's where it has been a change in a base pair with this particular sequence, which possibly has resulted into a change in the actual protein that is coded for in this particular area. But we're not finished yet. So what I'm going to do next, I have to actually translate both of these particular genes into proteins, and I'm going to align the proteins using another software called Cluster, and I can align multiple sequences, and that'll tell me in particular which amino acid was coded for with this mutation. So I'm just going to translate both of my two genes into their protein form or amino acid form. So we're just going to go to translate, and we're translating. But well, first, before I translate, I'm going to select the basis that I really want to key in on, and that's going to be from 3,078 to 6,002. And I'm going to do that for both the SP4 and the MSH2 gene as well. So we're going to just press select. So it highlights it, and now I'm going to translate it. Translate it, and we're going to use one letter codes. Okay, as you can see, I have my translated sequence for the SP4. So I'm just going to go and do the same exact thing for my MSH2. So I'm going to go to select from and change that to 6,302. Okay, and we're going to press select. We're going to translate this as well. One letters for the codes. Okay, so now that we have both of our sequences translated, now it is time to move on to the other software. So what I'm going to do, I'm just going to switch over to the software. And as you can see, it's called multiple sequence alignment. And this link can be found on Moodle, or you can just Google EMLEBI, and it's a software, well, not necessarily a software, but website that can do translations for you. So I'm just going to press the cluster omega because that's going to take me to the multiple sequence alignment. And I'm going to first name each sequence that I will be aligning. So first I'm going to start with the plasmid. So we're going to do we're going to name it PMSHS. H2, I'm sorry about that. And then I'm just going to go and copy that sequence. And it's really important that you align it in the correct order, with the plasmid being on the bottom. So I'm just going to go and stick the SP4 in front of it because you want the plasmid to be under it. And you'll see once I align the two genes. So I'm just going to go and make sure you put the little greater than sign, because that's the only way it's going to recognize that you have two sequences, and it's going to align their name. And you will see that once I align these two genes. So I'm just naming it SP4, and I'm going to go and get its translated codes. This is SP4. I'm just going to copy it. Okay. Everything looks good, and I'm just going to leave everything as it is, all of the other settings at step 2, and just go ahead and press submit. And I'm just going to wait for it, and it's running our sequences right now. Okay, as you can see our two genes that have been aligned for us using the cluster omega. And if we look for, I found it. Okay, it is right here, and you can see the mutation, the particular point mutation that has occurred, and you can see that that point mutation resulted in a change in amino acid that was coded for in that particular sequence at that particular location. So I'm just looking at a codon chart right now, and as you can see for the PMSH2, initially what was coded for was guanine, and what was the code during the mutation is serine, and that particular amino acid is a really bad mutation, point mutation, since it did result in a change in the amino acid, because one of those amino acids is non-polar and the other one is polar. So at that particular point, the strand is not even going to connect based upon the chemistry of this particular codon or protein. So as you can see, that's where the point mutation affected that particular gene that was coded for, and it went from being guanine to serine. And you can see how I align my sequences, and this can easily be done using APE and Cluster Omega software. That's it. Thank you.